Good morning, everyone. Thank you for joining us for this morning's webinar. We have myself, Seth Frumkin. I'm the Vice President of Kipcon, my father, Mitch Frumkin, who is our founder and president, and Jeff Payne also with us, who is our Marketing and Business Development Manager. So with those introductions, we're going to get started. You'll hear from me first, and at some point in the middle of the presentation, we'll switch over to my father to talk more specifically about the second half of the presentation.
Okay, I'm going to turn it over. I'm going to share screen, and I just sent just a little chat to everyone that if you have questions during the presentation, please feel free to drop them into chat or to jump in and start talking. And don't be shy, because the thing that makes this the best is being interactive. So if you do put it in chat, whoever's not talking will be the one to facilitate the question to the speaker. So with that said, I'm going to share my screen, and everybody should see the PowerPoint. And also, people really like the idea that we put the closed captioning on the bottom, so we will continue that. And if anybody likes this webinar and somebody doesn't attend, we are recording it, so you will be able to see it later.
Great. All right, the topic for our webinar this morning is selecting the engineer and contractor for your projects. A lot of projects come up in the communities, and commonly the engineer is involved, as we'll see later, in assisting to select the contractor. So that might be more commonly understood, the procedure for having someone involved in selecting the contractor. But something that is not discussed as frequently is, how do you select the engineer? So that's something we've added in as well, even though as engineers we're a little biased, but we'll stay as objective as we can. So the subtopics will be, Lisa, why is an engineer needed to begin with, and how to select the right engineer, establishing the budget for engineering. This is something that comes up very commonly. We're asked about this, specifically in regards to contract administration, that phase of a project, which we'll get into. Then moving on to the contractor, how to select the right contractor, and establishing the budget for construction. So first, why do you need an engineer? And before going into these specifics, I think it's important to mention that it's good to have an engineer involved, forgetting about any of the technical aspects, just to have an objective third party involved at all. The contractors involved, if you choose the right contractor, typically they're very experienced and they know a lot about these projects. They've worked on them, but at the end of the day, it's important to have someone involved who's kind of an objective third party looking in from the outside, who's not involved in the details of the day-to-day project itself, and who's ultimately whose compensation is not dependent on the quantity of products being used or the ultimate quality of the product at the end. So just having a third party involved is good. Specifically for an engineer, it's to provide technical expertise. As I mentioned, the contractors, if you have a good contractor, they're going to know, for the most part, the details of the project. They've worked on a lot of these projects before, but to have an engineer who has the technical background in whatever area of project you're working on, can point to the specifics in the code, and has the educational background and licensing. It's good to have someone like that involved for peace of mind, comfort, and to make sure that everything is specifically in the place that it should be. Secondly, to prepare the RFP, we'll talk more specifically about a request for proposal. That is a key phase in this process, because if the RFP is not the way it should be in the beginning, then it can just lead to exponential confusion down the road. If you don't have things apples to apples, you don't have the right things being asked for, described correctly in the proposal, it just can get very, very confusing very quickly. So it's important to have that first step really set in the beginning. And then ultimately the third phase would be to oversee the actual work being done at the time of the construction project. a lot of times, you think of the engineer being involved in the beginning, preparing the drawings, the specifications, but to have them involved in the project and whatever frequency that would be, whether it's full-time, part-time, and that will depend on certain projects, what type of project it is. We'll talk about that later. But the third phase is to have the engineer involved during the course of the project as well. What are the construction documents? It's really broken down into two separate items. The first is the design drawings. Those are the blueprints you see in the picture here. It's a little hazy, but in that picture there, you have the blueprints, which shows the more of the images of what's going on in the project. And then the specifications, which really is referring to the written documents of going through more details. So the design drawings, ultimately they are a graphical representation of the proposed project, which identifies both the existing as well as the proposed conditions that are used to define the project. And more, as it shows there, the key word would be graphical representation. Whereas the specifications are the written portion of the construction documents, which describe the specific products and quality standards required for the construction of the project. They are not intended to define the means or methods for execution of the project. That is very important to mention. That is the contractor's responsibility. The specifications will say what needs to be there. The contractor will typically determine how they want to go about getting to that ultimate goal. So where to begin? The starting point sometimes is very confusing of where to begin. If you have a project, let's say a roofing project, well, depending on the specific goals, needs, and of the association and the condition of the roofs, maybe it's best to start out with an inspection. Maybe you want to have invasive testing. Maybe you want to go right to the specification phase and replace all the roofs. Maybe you're not sure and you want to phase it out. So it's very important to have a discussion initially and determine what is the right point of entry into the project for your community. Some specifics when it comes here, let's say this is for a paving project, does the water stand for days? If it does, is it at one location or many? These are important points to mention in the beginning of the project. Are the decks falling apart and need to be replaced or right away, or maybe they should be inspected first to determine if there's a repair that can be done to avoid the fees for a full replacement. Are the roads ready to be replaced? Is there cracking? Are there potholes? Is there standing water? Just because, let's say, a reserve study says that the roads are due for replacement this year does not necessarily mean they need to be replaced. You want to definitely take a look at them and come up with a plan that's specific to your community. And also, what are the expectations when the work is completed to make sure that at the end of the project, for example, for a paving project, it's common for there to be under certain conditions and scenarios cracking within the first year. Something that's unavoidable. And those expectations are very important to be set from the beginning, because you don't want to spend a few $100,000 or more on a paving project. 6 months after the project is finished, you see a crack, and that could lead to some serious stress within the community, when if the expectation was just put forth in the beginning that that's something which is expected, then a lot of headache can be avoided. So what is the RFP? The RFP is essentially a document that solicits a proposal by a community association or others for engineering services. And this is the RFP for the engineering services. It's typically used when the request requires technical expertise or specialized capability. It's used to provide a method for objectively evaluating expertise, experience, and fees, and to have everything apples to apples together. Some specifics of what the RFP should have for the format of the deliverables is, do you want a report with recommendations? Do you want specifications? Do you want both of those? Do you want design plans? Should it include a cost estimate, specific testing, meetings, others? As engineers ourselves, putting together a proposal, we try very, very hard to communicate in the proposal with italics and bold in certain areas, because we know that these are all questions that come up down the road. And we try very hard to account for everything in there. But if an RFP is put together where the client is communicating specifically what they need, it's much more helpful to avoid a scenario where a specific line in the proposal from an engineer was missed, or you didn't realize that the reason engineer A's price is 25% less is because they're not including a cost estimate when the other engineer assumed you wanted a cost estimate. So again, very important to have an RFP to make sure you're communicating exactly what you're looking for, and so that the engineers know that they're bidding against what you're looking for. So you want to outline, have an outline form with specific sections. One document should be distributed to all the bidders, and try to avoid cutting and pasting from another engineer's bid. Sometimes, and I know it can be viewed as a way to save some work. If, let's say, you ask one engineer to submit a bid for something, then you take that bid, turn it into an RFP, and send that out to multiple engineers. And there are reasons that can be helpful. It can save time. And, at the end of the day, it's the association may not know what they're looking for, but just keep in mind that when you do that, you're already starting from the point of using what that specific engineer thinks is applicable to your project, and then assuming that is correct and distributing it to other engineers when that may not necessarily be 100% what is needed in the case. Could be, but not necessarily. So you want to develop an outline and again, separate the RFP into clearly defined sections. The project description, that is very important, is to, you want to identify what the scope of work is. You want a description of the project, keep it, not too long, get the main points in there, the reason for the project, why are the roads being replaced? Why are you deciding to replace the roofs? Are they leaking? Is it just you don't like the way they look, combination, and the location of the project. What are your goals? What is the purpose and objective of the project, and what will be the end result? And of course, a description of the community, the number of units, the common elements, the age of the community, any previous work done, when were the roofs last replaced? Have you been doing repairs to the roofs over the last couple of years? The location, and the building type and construction. And you're going to want information on the company that will be submitting the bid. A description of their company. Maybe you ask for related experience, projects, maybe similar projects they've worked on in the past in your area, references to call, what qualifications and licenses for people performing the work do they have, how many people maybe will be involved, will be multiple teams, crews, technical approach to the project, including potential alternatives. Maybe you want to ask the engineers to take a look at, bid on not only what you're planning on doing, but maybe if they have, in their experience, other thoughts as to different approaches. Maybe you want to hear those as well. Key schedule milestones. Will it be full completion or in steps or stages? What information will the engineer need from the association in order to complete their scope of work? And a grading and selection criteria, so they know what you're selecting against. So how do you make sure you're evaluating apples to apples? You want to look across the board at recent comparable experience for the different companies, their technical approach, specifically in regards to value engineering. What is their ability to meet the deadline that is important to you? Sometimes that's a question that's overlooked in the beginning. You're speaking to an engineer or whoever it is, and it sounds like they have the qualifications to meet the work, and they like their approach. But when you get started, you were expecting that they were going to start the next day and have a specification or a report to you within 2 weeks, and they're now saying after the contract is signed that they can't start for a month or two. So you have to make sure that it it meets your specific deadline. And of course, what are the fees? So you first take your list of requirements from the RFP and put them into a spreadsheet. That's the easiest way to do it. You have the different documents that have been submitted from the different bidders together, and put them into a spreadsheet line by line. And that way you can evaluate the highest and lowest for, and also for adding any missing items that might be there. If you're looking at, in one document across the spreadsheet, you'll see if there are any blanks from any of the bidders. Remember, when you're dealing with engineering fees, ultimately it's recommended that that's not the deciding factor, as really at the end of the day, they're a very small fee in comparison to the overall project. Now, if you're looking at a specification price from one engineer, it's $4,500, the other one is $5,000. It's really silly to make a decision based on price there, especially for that level of specification. I mean, you could be talking about a project that the construction costs are going to be in $500,000 or more. So to make a decision on what engineer to use based on a $500 difference in the beginning should really not be much of a significant factor at all, especially when that engineer is going to be taking a lot of responsibility involved for all the phases of the project. You really want to make sure that you're going with who you feel like you work with the best and is going to deliver the highest quality product, assessment, and oversight throughout the project. So the third phase that the engineer is involved in is contract administration. That is during the course of the project when the engineer is overseeing the construction process. It's important to have an engineer here not only to determine that the work is proceeding in general conformity with the contract documents, and I say general because most commonly the engineer is not there full time. They are on site periodically just to kind of check in. This is typically what's needed. The assumption is that the contractor knows what they're doing, and the engineer is there periodically to check on the general conformance with the documents and make sure that what's being done is according to the contract. Now, it could happen you run into scenarios of, let's say, unforeseens, or if for some reason the contractor has been working in a way that's somewhat concerning, you may want the engineer there more commonly, but that's not the goal. We don't think that the goal should be that the engineer needs to be there full time. But this is also important. Oh, sorry, could you just go back to the last slide for 1 minute? Thanks. But it's also important because for a final punch list, it allows a final opportunity to detect the need for additional work, monitor the costs, and prepare a punch list. So, if things go according to plan, which they almost always do not, for a large construction project, you will not have any unforeseens come up, and you won't have to tap into the unit cost pricing. But most of the time, that does happen. I mean, when we prepare cost comparison, bid comparisons, we typically tell associations, don't even look at the base bid number that the roofing or pavement contractor has submitted. You want to assume something in the 10 to 20% range, more than that, for base course repairs, plywood replacement in the roofs, things like that. So while it may not be important to have the engineer when things are going according to plan as much, if the contractor gives you a call and says, hey, we just started the project, we took off the top layer of pavement, and what we're seeing is much different than we expected, it's going to be very helpful and comforting at that point if you have an engineer to call and say, can you get right out to the site, take a look at it, and tell us, help us work through this and determine, if we need to do additional work, and if so, what would that be? So just some of the specifics of what's done during the contract administration phase is the engineer will facilitate the communication between all of the parties, the contractor, the owner association, the manager. The engineer will be involved there, kind of helping to facilitate as an objective third party. The engineer will also prepare progress and final punch lists. They'll walk through and should submit to you regular reports from their visits as to what items are still pending, and that will be a working list throughout the project. So you know that the contractor is fixing and finalizing all of the items. Sometimes just a final punch list is okay. Progress punch lists are definitely important in instances where at the end of the project, you won't be able to tell or fix certain aspects from the middle of the project. For example, with pavement, once the base course is covered up, you can't really make any changes to it at that point. You don't want to rip up your new pavement to make a fix to the base course because you didn't get to it before the top course was put on. And of course, reviewing invoices for progress and final payments. The payment terms, of course, will be determined, and that's up between the association and the contractor. Sometimes the contractor will want deposit up front. They'll want, payments across periodically. Sometimes they're okay with a payment just at the end, or one in the middle and one at the end. But either way, you're going to want somebody reviewing those invoices and comparing them against the specific number of products and services that have been used to make sure that everything matches with the proposal and that the payments line up. A very common question and a good one is how much contract administration is needed. Do you want the engineer there full-time, once a day, 3 times a week? And if they're there 3 times a week, how often should they, for how long should they be there? For 2 hours, the whole day, just in the morning? Should they come back at several times? And the answer really is going to be that it depends on the phase of the project. It depends on the association and their comfort level, the contractor, and the type of project that it is. But I would say it's very important to discuss and hear from the engineer in the beginning, and also to tell them, what you think of how much they should be there, but to hear from the engineer how often they think it's important to be on the project for contract administration. So initially, to kick off the project, there's typically a pre-construction meeting between the client, the engineer, and the contractor. This is just so that everyone's on the same page. You've gone through the whole procedure of getting the specifications done. You've been talking with different contractors. Maybe you had contractor interviews. You finally selected the contractor. It's good to now just have a meeting with everyone involved, maybe walk the site, see things in person, look at things together, see the people in person, or half of them, with masks or whatever you're doing, but to make sure everyone's on the same page. You want to review the location and services being provided and outline timeframes. Hear from typically this is, done in the bidder selection phase, but just go over again to make sure that everyone's on the same page with when is the project starting, how often will the contractor be there, what are the target milestones, when, is it a building per week? Is it, to pave 1 court per week? Where will they be starting? Are they going to do the main roadway first? What will traffic be like? All these things are very, very important to have clear in the beginning. At the time of demolition, you want to see what's under that which is being demolished. Very important. This is a key time for the engineer to be on site, because there's only a limited time period when you're able to see what is under the demolished material, whether it's the top layer of pavement, the roofs, etc. I mean, the contractors, as you know, if you've been involved in these projects, they work quickly and they do not want to wait. So if they remove the pavement or the shingles, they're putting the new ones right back on right away, typically. So you want to make sure that the engineer is on top of getting out there to see it, so that if anything needs to be changed, it can be, or at least even just to document, take pictures, so that that pavement which was underneath was in good condition, and you have a picture of it, you have it in the file, so there are no questions at the end of, well, we trust this contractor, but we never really saw what was underneath, so there's no proof or any way for us to really determine if what was under there was in good condition. And again, this could lead to adjustments to the specifications. That's the main reason for seeing what's underneath. During the rebuild phase, you want to take a look at what materials are there. You want to make sure that the materials are correct. We had an experience a few years ago where a roofing contractor delivered the wrong roofing materials to the site, and they were just about to start putting the incorrect roofing system and shingles onto the roof. We had one of our guys call and say, hey, I'm not really sure if I'm seeing what I think I'm seeing, but I don't think this is the right roof here. We, of course, right away compared it to what was specified, and it was true. It was not the correct roofing system. The contractor had mixed up projects. This site's roofing materials were at another site and vice versa. And of course, the project had to stop. It made some painful delays in the project, but at least at the end of the day, the correct roof was installed. Now, for these materials, this is something that would have been noticed after they were installed anyway. It's not like the, let's say, the bottom layer of pavement where you only have the limited window to see it. But of course, at that point, it would have been an even bigger problem if the roof was already installed and it would have to be pulled off. Just you can imagine it would have been a complete nightmare. It was a little bit of a nightmare anyway, but would have been a much worse nightmare if the roof was already put on. And then, of course, at the completion of the project with punch list to walk through, you walk through the site with the engineer, with the contractor, and then you just go through the list, point out specific things, you see it in person, and you work out a plan with the contractor to come back and fix any items that are left open. So the preparation of the proposal. You may find that the engineer will want to visit the site prior to preparing a proposal, just to make sure that they are fully aware of what the conditions are on the site. Sometimes over the phone, hearing a description of an issue or reason for that the association is requesting a proposal does not necessarily match what the engineer may see on site. And with the engineer's experience, they may see things that the managers, as experienced as they are, may not notice. And that might be helpful in preventing any changes to the project later on down the road. It's important to clarify who are the contacts in case the engineer has specific questions. Who should they be reaching out to? Is it the manager? Is it somebody specifically on the board? Is it both? Who wants to be copied on the emails? Do you want to be copied by email, by phone? And who should receive the proposal? Should it go to the manager? Should it go directly to someone on the board? And of course, when is the proposal needed? Very important, kind of starting at the end with, we like to start with when do you want the work done? And then work backwards from there to determine, well, if that's the case, then each phase, which is X amount of time long, should start at this point, working all the way back to when the proposal should be, for sure, should be submitted. Maybe you have a meeting coming up. Sometimes meetings don't happen so often. So if the meeting this month is missed and the only opportunity to present the proposal is at the meeting, then another month is going to go by until it's presented. So definitely make sure the engineer is aware of when you need the proposal by. Specific terms that would be in the proposal are what types of errors and E&O insurance and indemnification do you have in the terms of the proposal? Auto insurance, general liability, workers' compensation, all this, the amounts typically are specified in the terms of the proposal of what's needed for this. Just one moment, I see a question here. Can the engineer penalize the contractor financially for not meeting a deadline? It's a great question. And ultimately what we would look to for this is back to the contract. The contract is going to be between the association and the contractor. If there's something in there specifically outlining that the fees or that we're dependent on a deadline, or there's a penalty from not meeting the deadline, then absolutely yes. If it's not in the contract, though, it would be difficult for the engineer to get involved in that aspect. So the engineering design and bidding fees. Generally, the engineering cost for the preparation of the specification and the design drawings, as well as bidding services, is a lump sum amount. So here we're talking about the first two of the three phases. You have the specifications, phase 2 is bidding, and phase 3 is the actual contract administration. So typically for the first 2 pages, for the specifications and for the cost to assist the association in the contractor selection process of sending out bids, those are typically lump sum amounts. It can be, it doesn't typically get into the hourly fees. When it comes down to contract administration fees, which is typically a much more common question, it's typically on a unit cost basis, whether it's hourly rates or daily rates. And this a lot of times scares people because, when an hourly or daily rate is thrown out there, you don't know how many hours is it going to amount to. That can add up very quickly, or how many days will it add up to. Although it's very difficult to put a fixed fee on this phase of the project, because as I mentioned before, we don't know what unforeseens may come up. So it's difficult to put a fixed number on, on this phase of the project where there's so many unforeseens. What can be done is, you can work out a schedule with the engineer in the beginning to give them, let's say, a cap of, not more than this many hours or days, or to talk specifically about what milestones you want the engineer on site for, which would limit it that way. And then you can work out what the general hours would be there. On a general basis, what the engineering fees typically come out to for these type of construction projects would be in the range of 4 to 6% of the overall construction project. The contract is between the community association and the engineer. It's generally prepared by the engineer and reviewed by the association's attorney, and describes the contractual requirements and scope of work. You'll have in there the payment terms, the insurances we mentioned before, commercial terms, and the schedule for the project. So in summation, basically, very important to pick the engineer based on the qualifications, not the fee. If you're talking about a very, very large difference in fee, of course, that's something you want to consider. But if, like I mentioned before, you're deciding between the $4,500 spec or the $5,000 spec, would not be advisable to make the decision based on that $500 difference when you have such a large construction project coming. And also to keep in mind that the ability to value engineer will make up for a difference in fee almost instantaneously. Thank you everyone for listening, and now I'll turn it over to my father to discuss selecting the right contractor.
Thank you. I'm sitting here listening, and as you know, Seth's my son. He's a little younger than I am, and he's starting to pick up my ability to talk, I think. So I was impressed. Very nice. As you know, I've been in business a little longer than Seth, and one of the things that always amazes me, and a great question, I'll get to that in a second, but one of the things that always amazes me is that associations do multi-million-dollar construction projects, and they hire an engineer to put together and do all the stuff that Seth talked about, but it's very rare that they actually put together an RFP to select the engineer, when the engineer is going to be in control of the entire project, but at the same time, they'll hire an engineer to do the RFP for the contractor. I have seen in the last couple of years that more and more managers are actually putting together basic RFPs for the engineering services. But typically we'll get a call and somebody will say, give me a proposal, please. We're replacing all the pavement in our community. And I'm sitting there saying, it's $1 million worth of pavement, and it's a phone call. And they don't even say what they're looking for other than the engineering proposal to do a specification. So it's left up the engineer to do the proposal. And then how do you even measure them compared to each other without having an RFP? But I am seeing, there's certain one management company in particular that just about every job they do that's engineering related, they actually send out an RFP. It's also interesting because managers and some of them don't have technical expertise. That's why they hire engineers. So sometimes the RFPs don't have 100% logic to them. And that's why Seth talked a lot about, what do you really want to get here? What's your ultimate goal? So I had to touch on that because it's very rare that there's an RFP for engineers. And we do a lot of seminars having to do with that because we think that it's very important. The other thing I'll say is, if you were going out to bid on some kind of job and you wanted some kind of basic template for an RFP for engineering services, feel free, email us, give us a call. And if we have it, we'd be happy to share with you a sample template. We only ask one thing in return. Let us be one of the engineers that bid on the project for you. All right, the question was, what is value engineering? Value engineering means that there are a number of different ways to do things. So I'll give you a very simple example when it has to do, for example, with mechanical equipment. If you call up an engineer and say, I have a clubhouse that has an air conditioning system, give me a price to replace the air conditioning system. Generally, what happens is you'll get a proposal to replace the air conditioning system with something similar to that what's there. Value engineering means, okay, well, there's so much great technology out there in high efficiency equipment and different things. I will give you a proposal to not put in there exactly what's there, but to value engineer it. So you might pay slightly more, but you add in the life cycle costs and it'll be a lot less, the cost of the energy and the equipment. One example of value engineering. Another thing is, let's say you're replacing a wood deck in a community. You say, I want to replace the wood deck. So you get a proposal to replace the wood deck, but the engineer may have some creativity, or hopefully have some creativity, and say to you, well, maybe you don't want to replace it wood. Maybe you want to replace it with the Trex, some kind of plastic lumber or something, rather than the wood, because I'm value engineering the project, not necessarily based on the first cost of doing the work, but the life cycle cost of doing the work. So that's what it means, that some engineers don't take into account value engineering. The other thing that we do, which when we put together a spec for work, which I'll talk about in a second, we generally put in our proposal to the contractor, do you have any recommended alternative ways to do this job? Because some contractors are very creative, and just by asking the question, they'll say, well, if you make this slight change to it, you're getting the exact same thing, but you can save hundreds of thousands of dollars by doing it this way. So that's essentially what the concept of value engineering means. I think it's really the creativity in doing stuff so that you can get it done for less and get the same result, essentially. And that's why, you may, like Seth said, you may save $500 in selecting the engineer, but the engineer you're selecting doesn't have the creativity in terms of value engineering. So that's essentially what it means. And also the contractor. So I'm going to talk about selecting the right contractor. The reason I'm looking to the right every couple of seconds is because I have two screens. The PowerPoint is over here and you're over here, so I'm looking into the camera. But a lot of the things I'm going to talk about is similar to when it comes to an engineer, but now we're selecting a contractor. And one other thing I wanted to add is, which I'll talk about the contractor, how do you find the engineers? You CAI directory, of course, but references are always great, those type of things. So there are sources to find engineers. One of the things, the way to do it these days, I mean, even from a marketing perspective, people put ads in the CAI magazine or things to provide engineering services. But when you select an engineer or a contractor these days, you may be looking at magazines, but what do? You're doing a Google search. I mean, that kind of thing is how you find people these days. But in the industry that we're in, community associations, it's a special industry. And what I mean by that is that you're dealing with occupied buildings. Most contractors in this world deal with new construction. You have to have a special technique and a special understanding when you're dealing with buildings that people live in, when you're replacing roofs, when you're replacing siding, all that kind of stuff. But so selecting the right kind of the right contractor. First thing I have to mention, I put this slide in here, is when is the right time to do this? Community associations are in a special place in our economy because, of course, people are struggling because of the pandemic and things like that. But at the same time, these communities have accumulated money for years and years and years in their reserve funds to do projects like roofs and roads and things like that. And the reason I mention that is for two reasons. The first of all, I think that we have an opportunity in our industry to really help kickstart and keep our industry strong, and the contractor is strong and the engineer is strong and all this kind of thing, because we have accumulated the money to do the work. We have the money. Now is a great time to do it, to help the contractors, to help the economy. And let's not kid each other, that because of what's been going on, you have the opportunities to get maybe better prices. more quality contractors because of what's going on in the economy. I don't want to fool you though, because in our industry, I think most people are doing this because most contractors and engineers are pretty busy. I know we're pretty busy and contractors seem to be pretty busy, but we have the opportunity to help the economy just because we've accumulated the money in our reserve funds. And that's a whole other webinar. We'll do one on reserve studies. As you know, we do a lot of those. But keep this in mind that where we are and how we can help our world these days. Getting better. Next year, hopefully I will be able to take this slide out of the presentation. So the construction projects for community associations are, like Seth mentioned, the typical types of things: paving, roofing, facade, siding, drainage, decks, patios, walls, all these kind of things. So these are the typical kind of construction projects for community associations. In certain instances, the same contractor can do multiple things. For example, there are contractors that can do roofing and siding at the same time. You know, that's their expertise. Generally, contractors, if you lump them together, do building work or do site work. And there's overlaps on the building and there's overlap on the site. But then at other times, it's a different contractor for the roof. It's a different one for the siding. And we're working on more and more, we see communities that get very much involved strategically in doing the work in their communities. And what I mean by strategically is your reserve study, or you may be planning on doing a roofing job, but you may be planning on doing a siding job also. So for example, we're working on one large community up in Marshtown right now, where instead of doing the roofs and the siding separately, they're probably going to hire one contractor, do it on a building by building basis, doing the roof and the siding at the same time. Because keep in mind, the roof touches the siding, and the intersection between two different things is critical. So to use two separate contractors is really not necessarily the way to do it. The other thing is that strategically, and we're trying to do this more and more in our reserve studies. Let me tell you, because one of the things is that, let's say you have a community that's going to do the roofs and then do the roads. Which one do you do first? You want to do the roofs first because you don't want to do the roads and then have a contractor driving over your brand new roads to bring shingles in to do your roofs. You want to do the roofs first, and then after the roofs are done, start doing the roads, so you're not destroying the roads by doing the roofs. So what we try to do as much as we can is, when we do reserve study, not only look at the condition of things, but strategically place the remaining useful lives in the reserve studies so that you're strategically doing the work so that in a proper order. So but these are the typical types of projects that are done. And you can see I go off on tangents with all kinds of stuff when I talk about this, but so these are typical types of projects. The reasons for the projects: ends of the useful life. Keep in mind that a lot of people don't use the reserve studies as a guide. The reserve study is a planning tool for doing projects as well as for accumulating money. So you should be looking at your reserve studies at the end of each year and saying, according to the reserve study, we should be doing this next year. There's a reason why it says it in the reserve study, but it's because the end of the useful life, review your reserve study, upgrades. Maybe you want to upgrade something. New amenities. Let's say you want to add a tennis court. Of course, natural disasters, flooding, ice damming, these kind of things. You've probably all been hit by ice damming recently. We're involved in a couple of ice damming where people think that ice damming is because a roof when a building was put together wrong. Ice damming is caused by snow on the roof and temperature at night below freezing and during the day above freezing, hot air in the attics, but it's not based on a construction problem. It's based on Mother Nature. But keep in mind, there are ways to prevent water from getting into buildings when you replace your roofs by doing putting certain rubber membranes under the shingles so that you know that ice damming and snow on the roof is going to happen. But when it does happen, it's going to prevent it from getting inside the homes by doing things when you change your roofs. So natural disasters, flooding, sometimes you maybe have to fix something. Ice damming is something that it really gives you a guide towards replacing your roofs. That doesn't mean you necessarily have to do it the next day, but what to do when you do replace the roofs. One thing that's kind of interesting, working on a project right now, which you won't believe it, and if you guys get my Kipcon Minute, I do a Kipcon Minute now probably once or twice a week. That's on LinkedIn where I get a lot of following. Today I'm doing one on termites. Believe it or not, I consider that kind of a natural disaster. We're working on a community where the termites have gotten in and eaten up the structure of a building, believe it or not. And I'm going to put pictures in the Kipcon Minute where now we're doing the engineering to replace the structure of the building because the termites have eaten away the beams and the columns so bad that they're structurally unsound. So I think of that for natural disasters. Fire, Reasons for projects, energy efficiency upgrades. There are some instances where there are such great incentives out there these days for replacing the mechanical equipment that you can get incentives to replace things. You don't have to take the money out of your reserve study sometimes because you get, maybe almost the cost of the equipment. So you may want to look at energy efficiency for a reason to do a project. If anybody has any questions on that, there's a great website. I'm going to put it in the chat right now. It's called DSIREUSA.org. Now, I just put that in the chat room. Now, if you go to that website, you're going to see a map of this country. Click on any state on there. It'll pop up with all the incentives that are available for energy efficiency upgrades. And if you want to see how to apply for any of them, click on it and take it directly to the application. New Jersey has some great incentives. And I'm not just saying this for your clubhouse or something. If you live in a condo where you're responsible for your air conditioning system and you're going to replace it, there's generally incentives for that type of things too. So take a look at that website, and that has to do with energy efficiency. So let's see, next slide. Sources of funds. Where do you get the money? One of the questions I always ask when a community asks us they're planning on doing a project is, do you have the money to do the project? Because let's not dream about it if you don't have the money. So it generally comes from reserves, assessments, borrowing, maybe insurance, some of these incentives I've talked about. But the other thing we get involved in a fair amount is association will say we're replacing our roads, and we'll maybe take a look at the reserve study to see based on how much money they have, will they need to phase the project over a number of years or or can they do it all at once? So we get involved in that a fair amount in order to make sure that the sources of funds are there. Worst thing that can happen is, even from an engineering perspective, you hire an engineer to do work, but you don't have the money to pay him. Or you hire a contractor to do a construction job and you don't have the money to pay him. So the sources of funds are very important for you to evaluate once you start getting into these jobs. This is just an example of a reserve study, how you look at it for remaining lives and things like that. All right, who are the involved parties when you get involved in construction? The manager, and I'm guessing that, generally for these type of presentations, usually it's about 3/4 of the people here are managers and the rest are homeowners. So I'm not sure what our audience makeup is today, but it's made up of community association, the board, the manager, the association's attorney, the engineer, and the contractor. And I'm going to show you what the relationships are. The classic way that construction projects are done, which I'm sure all of you do, is called a design, bid, and build it, which means that you design it, you go out to bid for it, and then you build it. There's other models like design build where the contractor does the design and the building. I'm not going to go into that because in our world with community associations, you hire somebody to do the design, you go out to bid, and you build it. So like Seth talked about, the engineer works directly for the owner, which is the association, design specs, selecting the contractor during construction, and also keep in mind that the contractor works for the association, for the owner. They do not work for the engineer, they work for you as the owner. So this is what the relationship looks like. You have the owner, who's the community association. You have the contractor and the design professional, but we all have contracts with you as the association. But then you can see the dotted line down here where there's a relationship between the contractor and the design professional, which is what Seth spoke about. But this is the general process. Who's the owner? The owner is the association. I mean that's you guys. You're the owners. There's no question in our industry there are what are called the gatekeepers, which are the managers, which are the gatekeepers to the owners. But the people that are actually signing the contract for all this work is the association. It's the board members. You're signing on behalf of the association. So that's who the owner is. Who's the design professional? Seth talked a lot about it. It's the engineer. So they're the design professional. Who's the contractor? The contractor is the person that's responsible for taking the specifications for agreeing on price and building it. So that's who the contractor is. And then we can't forget the attorney, because the attorney, no matter who does, we as the engineer does a contract. Let's say you do a contract between us and the engineer, or there's a contract between us, you and the builder. The attorney should always review the contract. You are not attorneys, we are not attorneys, the contractors are not attorneys. So there's always an attorney in the link, especially on big projects, to review the contracts in terms of insurance, in terms of indemnifications, in terms of all of these type of things. But the attorney is generally in the loop and should be in the loop on the bigger projects. There's no question about it. For example, if it's a paving or a roofing job, the attorney should be reviewing the contract. A lot of times what happens is that we'll put together a specification for the work, but the attorney will draft a contract that ties everything together. So the attorney is definitely a part of it. Specification sections, Seth had talked about this. Major projects, and Seth talked about this, so I'm not going to touch on it, and there's a lot of overlap. But now we're talking about the contract between not the engineer and the association, between the contractor and the association. So there's special and general conditions, and it defines the relationships, the method, and the conditions of payments. For example, when you're dealing with an engineer, our contract is generally based on progress payments. When we're 20% through with the project for you, we get paid for 20% of the work we've done. It's different for a contractor typically. And what I mean by that is the contractor doesn't get paid in full during progress. There's what's called the retainage. And what the typical model is that, let's say we're doing a roofing job, just as an example, it could be a road, it could be anything, but you're doing a roofing job. The contractor finishes a building. Let's say that building is at $10,000 for that one building. The contractor does not get paid that $10,000 immediately at completion. They get paid, let's say 90% of it is the typical model, with 10% of that cost being held back. It's called retainage. That retainage is released usually after the engineer does the inspection, the contractor fixes any punch list work. Let's say they rip a screen or they damage landscaping or something. Then the engineer reviews, and once the work is done and all punch list work is done, the contractor is paid that 10% retainage. But most of these contracts are based on our retainage. When you talk about payment schedules, I'm against paying contractors for construction work upfront. And the reason I say that is because let's say you pay them for all the materials upfront, and then they go out of business, then you're stuck. But if you use these type of progress payments with retainage, even if a contractor goes bankrupt, which you don't want it to happen, or they walk away, you don't want it to happen, but they've only been paid for work they've been completed. They haven't been paid for anything they haven't done yet. Now, I will say it's different from an engineering perspective, because typically our contracts are based on signing a contract and paying us a retainage to do the work. But typically, it's very rare on a construction job it's done that way. We generally recommend against it. Project schedule. Now, Seth touched about that. Somebody asked the question about project schedule. Can there be damages? Absolutely. Exactly what Seth said. There are contracts between the owner and the contractor that is drafted by the engineer and reviewed by an attorney that may say a contractor agrees to complete the job in a week. If they do not complete it in a week, there's a couple of types of penalties. Maybe it costs them money. The most common thing is that, let's say you have to do additional engineering inspections because the job is taking longer. The general penalty I've seen is that the contractor, if they don't meet the schedule, is responsible for paying the engineer for any additional inspection time that was not anticipated because the engineer was hired based on a certain certain schedule. So, but you got to put a very important asterisk on that. And that is two things. First of all, if the contractor says they're going to finish something in a week, the contractor really is not writing it correctly, because it's completed in a week based on good weather conditions, because they sometimes may not meet the schedule because the weather is bad. That you can accept. The other thing, if it's a $10,000 job and you take it apart and there's extra work that has to be done, then generally the schedule is extended if there's additional work. Now, let's say it goes from a $10,000 job to a $12,000 job. Then generally just the rule of thumb is you extend the schedule based on the same percentage as the increase in the contract value. So if it goes from 10,000 to 12,000, then it's a 20% increase in the schedule, because you can't hold the contract to a schedule if there's additional work that needs to be done. So these are in the conditions. Insurance is in the general conditions. These are insurance certificates. Indemnifications. If there's a lawsuit with the contractor, generally the contract includes indemnification that says that if it's against the contractor and the association is dragged into that, or the engineer is dragged into it, or the management company is dragged into it, the contract includes what's called an indemnification, which means the contractor will indemnify anybody else that's dragged in for something that they did. So it says contractor will indemnify and defend. What it means is defend means that if we're dragged in or the management company is dragged in, not only will they pay for indemnify you, but if you have to hire a lawyer, they'll pay for your defense costs. So these are the type of things that go into contracts and between the association and the contractor. I will put a little asterisk on there. Sometimes an attorney will ask in a contract between the association and an engineer to have an indemnification clause. Generally, we accept them, except if it says defend. The reason I say that is because our insurance company, insurance policies, our errors of omission does not include the defense of anybody else. It only includes the defense of us. But with a contractor, it's a little different. So the conditions include, Seth had talked about schedule of values, how much does it cost for each portion of the work so the money is released, quantities, allowances, unit prices, these type of things. Now there's something that's called a 702 form. This is called a schedule of values. What it essentially means, and I'm going to run out of time, so I'm going to go fast, but a schedule of value means that if you're doing 10 buildings, $10,000 each, this schedule of value will list building 1 through 10, what the value of each building is, so you know before construction starts how much the contractor is going to get paid for each building before they've even started it. So they finish building 1, they say, we want to get paid $10,000. We already have the schedule of value set up so we know how much they're going to get paid for that building. And then there's actually a column in here that says retainage withheld until punch list work is done. But that's what the schedule of values actually is. Types of projects, lump sum unit prices, cost fee combinations. Now I wanted to show, or I'm going to skip that slide for a second because I have a little diagram that shows performance bonds. A performance bond means that if you ask a contractor for performance bond, you're going to pay for it. It generally costs a percentage of the construction cost. I will tell you, the higher the cost of the performance bond from a contractor, to me, it shows the less strength they have financially. But a performance bond means if they go out of business, the insurance company will come finish the work. Based on the payment schedules I talked about before, where they're not getting any money up front, I don't really think you need a performance bond because you're only paying them for what they do. And if they do go bankrupt, you'll hire somebody else to finish or they walk away and you don't really need a performance bond. I also talked about deposits, why I'm against them. General conditions include what kind of guarantees and warranties, roofing job. You know, there are so many different warranties for roofs. Sometimes I make the argument that the warranty is more important than the shingles you're using. So warranties and things like that are in there. Or do they have to be a certified installer for that material? Who's the communication? Should the contractor have somebody on the job full time? Who's getting the permits? It's generally the contractor that gets the permits. All these kinds of things are in the contract with the contractor. Also, is the pre-qualified bidder list. We're bidding on a big facade restoration project yesterday or the last couple of days. And one of the discussions was, how do we select the contractors? They know what type of siding they want to use. So we want to make sure that the contractors do work are approved to install that kind of siding. So issued for bids, you have a pre-bid conference. A lot of these things are very similar then when you select an engineer. I mean, when you get back to an engineer, I would always suggest you have a pre-bid meeting with the engineer. Meet the engineers, either before or after they put in the proposal. Meet the contractors. There has to be a comfort level. With contracting work, the fee is much more important than with engineering, because engineering we talk about is 5-6% of the total cost, but the total cost we have seen for construction jobs can vary all over the place. They can be, the construction cost can be there can be a big difference. And I do want to mention this thing, I think I passed it, all right, maybe I'll get to it. It has to do with firm price versus lump sum. I'll get to that. This is the agenda for the bids. This is, one of the questions that comes up is, what is a contingency? If you have this is a typical bid sheet. It has all the different parts of the bid, contractor A, B, C, D, so you can compare them. Like Seth used the term apples for apples review. So you review apples for apples. It does two things. It shows who's the higher bidder, but it can also show a mistake that was made by a contractor in their bidding the job. For example, if you know, we usually ask for the quantities in here too. So if we see two contractors bidding on something, one says there's 100 square feet of roofing, the other says there's 102 square feet, the other one says there's 300 square feet, they made a mistake. That doesn't mean that you should disqualify them. It means you should ask them the question and say there's a difference in the quantities. You may want to check it. But that's why this apples to apple comparison is very interesting and very important. All right, now contingency. This is two typical types of projects. On the left is paving, on the right is roofing. Similar but different. On a paving job, you look at the surface of the paving, which is the top, and then you peel that all off and you put a new top on. On the roofing, you look at the shingles and then you take off the shingles and you put down the new shingles. But what happens is it's very easy to get a lump sum firm price to peel off all the paving and put down new paving, or to pull off all the shingles and put down new shingles. Where you run into trouble is once you pull off the paving or you pull off the roofing, what's underneath? What's the damage? What's the additional work that needs to be done? So it's very important that you not only look at the lump sum prices in the contractor's bid, which is the cost to do what I just said, but you have to look at their unit prices. For example, on a roof, how much does it cost to replace a piece of plywood that's rotted? How much does it cost to fix a pothole or something underneath the pavement? Because sometimes those unit prices add up to more than the firm price for doing the work. You have to be very careful. So when you negotiate a project construction, if there's a lower price for paving removal, but the unit prices are much higher than the other guys, you may still decide to use the other guys just because you're going to get killed on the unit prices when they peel it up. So that's why the question for construction, you get the bids from the contractors, you compare the total cost, but then you don't know how much the unit prices are going to be. So we, as a general rule of thumb, not for the contractor to see, but for you as the board and the associations to see, we generally will add 15% to that cost for budgetary reasons. You don't show it to the contractor, but you know in the back of your mind that we better set aside 15% additional because we're going to run into conditions that we can't see. If we see that the paving is very bad, we may say put in 20%. If we see that the roofs are very bad for some other reason, we may say use something other than 15%. But the general rule of thumb is take the contractor's cost that you decide on and add 15% to it because it is going to happen. My rule of thumb is I'd rather tell you a higher number, not go over it, than a lower number and have to come back to you and say it's more. But you never know until you start taking things apart. It is absolutely critical when you evaluate the contractor's bids. So you send it out to bid, you have a post-bid interviews, you meet with the contractors. Then the purpose of negotiating with contractor, keep in mind, in our world, you don't have to take the low price. It's negotiated. You meet with them. If you love a contractor, you know they do great work, but they're a higher price, there's no reason why you can't talk to them and say, we need you to reduce your price slightly to get this job. Well, there's no reason why you can't hire a contractor that costs more if you know they do great work. I mean, it's same for engineering. But the other thing is, like I said, in the proposal to the contractor, we ask them any value engineering ideas they have. Do they have a suggestion on a way to do the job the same way, but for less expensive? So value engineering from contractors is important. Confirm low bids, talk about the schedule, we talked about that. If you want a performance bond, cost savings based on payment terms, be very careful. Some contractors say, if you pay for all the materials up front, I'll take 10% off. I don't think you should do it because then you're not paying them based on progress payments. You've got a lot of money locked up with them in case something happens to it. I would be very leery about that. You have to let them know working hours, where are the dumpsters going to go? Where's the material going to be delivered? All this kind of stuff. So part of the negotiation, you really need to talk to the contractor. And the key to this, when you talk to them, is have you worked in communities where people live there? Because if you have, where do they park their cars when the paving is going on? Where do you put all the shingles when the roofs are being done? How do you notify the people? How do they get in and out of homes? So negotiation is very important to the contractor in communities where people live there. Negotiation, again, it's the same thing. The contract is between the association and the contractor. It includes payment terms, retainage, warranties, insurance. Are they confirmed? The other thing is a lot of contractors and big jobs use subcontractors. So the contract with them should always say, are you using a subcontractor? And if you are, who are they? I'm not saying you shouldn't use them if they use subcontractors, but most roofing companies, when they get involved in big roofing jobs, they subcontract out crews to work on buildings. So you want to know, are they using subcontractors? And let's see, the contract is fine. And some people say I don't need it. The only time you need a contract is when you have a problem. So that's why you need a contract. When problems occur, they are the primary source of what should be done and what should not be done. Should describe the work to be performed, cost of work, all this kind of stuff, talked about it before. Who is responsible? This is very important because Seth talked about construction administration by the engineer. Don't worry, I just have 2 slides left, I think. Seth talked about the relationship. You have to remember, the engineer does the plans that say what should be done. the contractor, the engineer is not responsible for means and methods, which means how does the contractor do it? What are the methods they use to do it? That's up to the contractor. So it's up to the contractor. The engineer says what to do. The contractor comes up with how they do it, means and method. Also, even if you have an engineer there full-time on the job site, the contractor is fully responsible for their work. They are responsible. The engineer is not there supervising the contractor. They're overseeing the work to make sure it's being done in general conformance with the specifications, but the contractor is responsible for the work. The engineer is your eyes and ears at the site, and they're not responsible for the means or methods, but the contractor is responsible for their work. And cost reduction techniques, consolidate multiple projects. I mean, if you're a manager, how many management companies have multiple roofing jobs going out to bid and have actually tried to go out to bid on more than one job at the same time? Very rare does it happen, but you can save money. You may be locked into the same contractor, but I remember a couple of years ago, I said to a manager, I'm not going to mention the company's name, by the way, we're doing a roof spec for the manager that sits in the office next to you. Why don't we go out to bid for both of them at the same time? The response was, no, it gets too complicated. But you might be able to save money. Not only that, if you're a manager, you do 10 reserve studies at the end of the year. Do you ever think of asking a company for 10 proposals instead of one for each? So consolidate multiple projects in the same type when bidding. Review the incentives. I talked about that. And let's see, when including maintenance. All right, I talked about this life cycle costs in terms of what you're going to use for your replacements. Minimize risk. Yeah, risk is a huge thing in our industry. I hate to say, but in many cases, people don't want to solve problems. They want to blame people. I mean, that's just, maybe it's the nature of every industry, but understand the roles of each party. Contractor is responsible for execution of the construction documents. Engineer is responsible for developing construction specs. Low price is not always the best price, not at all. And when we select contractors to bid on projects, I promise you, we are not going to put on a bid list a contractor that we know does bad work. It makes us look bad, it makes you look bad, and it's terrible. And the scariest thing is when a board member says, I have a brother-in-law that does roofing jobs, put him on the bid list. Scares me to death. So be very careful of that. Generally, we propose a list of maybe 4 or 5 contractors. The manager of the association looks at it and says, take this one off, add this one we've done work from before. And that's generally how we develop the bid list that goes out to the contractors. Establish payment terms, I talked about this, and match the services needed with proper expertise. Again, whether it's an engineer or contractor, I think it's very important, especially these days, it's easy. Have a Zoom meeting, go over the project, and feel a comfort level with who's going to be doing the work. So with all that said, I went pretty fast. Any questions or anything about anything? Nobody? Come on, we didn't cover everything. All right, well, thank you very much for joining us. I hope you got something out of today's presentation from me and Seth. And if you ever have any questions, feel free to email us, text us, whatever you want. And like I said, if you ever wanted to see a generic engineering RFP, let us know, and we'll provide you something that you may want to use, as long as you let us bid on the project. That's only requirement. So thanks, everybody. Have a great day and be safe. I really appreciate you joining us today. And I see that there's no questions, and I'm 9 minutes late, which is against my rules, so I'm sorry. Seth talked too slow. It's all his fault. So have a great day. Thank you very much.